Okay, next we're going to talk about exceptions. So typically, error checking code is tangled with the code that provides normal functionality. So here we have a function called foo, which maybe takes in an integer number, and we're eventually going to divide by this number that gets passed in. So in order to be safe, we want to make sure the number is not equal to 0, right? Because we can't divide by 0. So if the number is not equal to 0, well, we will take x and divide it by num. Okay, but if num is equal to 0, obviously we can't divide by 0, so we have to ask, well, what do we do? Do we print an error message? Do we get a new value from the keyboard? Do we just kill the program? Do we do something else? Okay. Well, removing this error checking code, right, will make the code easier to read and also easier to write, because it might be unlikely that 0 is ever sent in. Right? This is really kind of a rainy day scenario, and rainy days don't happen every single day. The decision about what to do is even harder if we don't know exactly when and how our classes are going to be used. For example, we can't possibly know every program that might use a safe array or a vector. If the safe array is used in a pacemaker, for example, it certainly doesn't make sense to print an error message. You can't get a new value from the user, and you certainly wouldn't want to kill the program. You might actually kill a person if you do that. So what do? Well, the author of the safe array class can't really say, because, like I said, they don't know where every single time their safe array class is going to be used. So traditional error handling techniques may involve when you call a method to return a true or a false value and leave it up to the caller to check what to do. So for example, let's say we had this foo function, and if everything went okay, well then the foo function would return true. And if anything went wrong, the foo function would return false. And if the foo function returns false, well then we can handle the error here. This is kind of equivalent to deferring the decision about what to do, take it out of the person writing the safe array class, and put it into the hands of the person who's actually using the safe array. Okay, we could do that, of course, but that leaves it up to the programmers who are using the class to do the check and make sure everything is okay. And from my experience, a lot of times what programmers will do is not do the check. So even though foo returns a true or a false, we'll just call it and assume everything is okay. Because like I said, most of the time it's a sunny day. Okay, only very rarely do we have to worry about these exceptional things happening. Okay, so that's where C++'s exception handling comes in. It allows programmers to handle exceptional cases outside the normal flow of control. An exception is an indication that some exceptional event has occurred. And these are usually exceptionally bad things that happen, not exceptionally good things. You can defer exceptional cases until later, or let some other part of the code handle it altogether. And the way we have exceptions is with these things called try-catch blocks. Okay, so inside a try block, we put some code where an exception may or may not happen inside that code. If an exception does occur in there, the flow of control will immediately jump to this thing called a catch block. And here we will handle the exception somehow. And then right after, the flow of control will skip to the first statement outside the catch. Now, if we're in the try block and no exception occurs, well, we just skip the catch blocks. So it's kind of like an if-else structure, but we get to pack more code in the try block than a normal if statement. Okay, so if nothing bad happens in the try block, the flow of control jumps down beyond the catch. Okay, so now we could kind of imagine the scenario here where we create a safe array that has exactly 5 elements in it. Well, depending on what value is inside num here, when we try and access this element, we might go outside the bounds of the underlying array. So that's exceptionally bad. An exception might get thrown there. Or if we're iterating through here, notice I'm using a hard-coded number here. That's probably not a good idea. So it's entirely possible that an exception could happen here. Or if somewhere before here we empty the safe array, or an exception could happen here as well. So we have 3 places where something bad could happen. Instead of having 3 separate if statements, we just put all this code in a try block, and if something bad happens, it will be handled in the catch block. Okay, and this code is easier to read and write because it separates the rainy day scenario from the sunny day scenarios. When an exception is thrown in a try block, a matching catch block is searched for. So we'll find out in a second. We can have multiple catch blocks. If one is found, the flow of control moves to the catch block and the exception is handled. And once an exception is handled, the flow of control moves right outside the try-catch block. If one is not found, the call stack is unwound, and wherever the current function was called will be checked and see, well, is that in a try-catch block? And if there's not a corresponding catch block there, we will back up to where that function was called, all the way back up to main. And if you get all the way back to main and no one catches the exception, no one handles the exception, then your program will crash. Now, in order to generate an exception, one uses the keyword throw. So here's our good old at function, where from the SafeArray class, that if the user asks for some index that's outside of the good range of values, what we'll do is we will throw a string exception and let someone else decide what to do about it. So the keyword throw, you can throw any piece of data, whether it's an int or a string or a more complex object. Okay. Then in your driver, when you call at, if you do that within a try-catch block, you can, if the exception is thrown, right, the flow of control will jump to the catch block, and maybe we'll do something here if it's a pacemaker, and we'll do something probably completely different if it's just a plain old Windows application. Now, like I said, we can have multiple catch blocks. The catch blocks are searched from the top down, so meaning here we might attempt some I/O, and we might get an exception like the end of file was found or the file was not found. 3 dots next to each other is kind of the catch-all. So you should definitely, if you are going to have this one, it should always be last, because these are searched from top down, and this will catch all exceptions. So what you can do then is create your own class, your own exception class, that exists really just to identify a particular type of exception. So here, out of bounds exception might be something we use in a SafeArray class. Okay. Well, then what we would do in our at function, if we know for sure we're going outside the bounds of the SafeArray, well, we can create an object of this type and just throw it. And if the code is the code hopefully is in a try block, and then we could catch the out of bounds exception type and handle it in a however application-specific way we would like to handle it. So in a pacemaker, we probably wouldn't print an error message, but maybe in a Windows app, that would be a good way to handle this exception.